Today we're going to talk about factoring in a slightly different way. So we're going to factorize some quadratics this time. We've been factorizing linear equations. Now we're going to look at factoring quadratics. So we've done it in the other direction. So we have done expanding quadratics like this, and we'll just remind ourselves of the patterns that we used. So we did the FOIL thing, right? Obviously we used this FOIL acronym we've been talking about, but remember there was that shortcut that I told you, and we're going to use that to help us do this in reverse today. So instead of doing FOIL, what I'm going to look for is the two numbers that add, so these two numbers here, 3 and 5, add to the middle term and multiply to the last term. So my first term is just going to be these two together, right? But then I'm going to say 3 plus 5 is 8. So that's where my 8 comes from, and 3 times 5 is 15. So that's where my last term comes from. So FOIL would give me this answer because I'd have 3x plus 5x, and then I'd put them together to get 8x. So that was our shortcut we talked about. We'll just do it again here with some different signs. So we've got our x squared as our first term. Let's put some equal signs in there. Then we're going to add these together. So negative 6 plus 2 is minus 4x, and then negative 6 times 2 is minus 12. So we're going to use this shortcut to do these questions in reverse. So this one up here, what we're going to do is look for two numbers that add to the middle term and multiply to the last term. So I want you to have a think for a second about what two numbers might add to 8 and multiply to 12. So hopefully you've realised there's only a few options. So the factors of 12 are 12 and 1. Well, 12 and 1 don't add to 8. There are 3 and 4. Well, 3 plus 4 does not add to 8. And there are 6 and 2. 6 and 2 do add to 8. So those are our numbers. So I'm going to write x plus 6 and x plus 2. It makes no difference where you put the 2 and the 6. Excuse me. So this bracket could be here and vice versa. It doesn't matter. So remember, the commutative law tells us it doesn't matter which order we multiply in. You still get the same answer. So that's why it doesn't matter which order those are in. Now, these look really similar, but I have a negative 8 here. So I need to find two numbers that add to positive 12, that multiply to positive 12 and add to negative 8. Now, hopefully you can tell. So when we looked here about differences of signs, if I need to add to a negative number, I'm going to need to have at least one negative value. But I need to multiply to a positive number, so that actually means that both of my numbers must be negative, because if both of my numbers weren't negative, I wouldn't end up with this positive answer. So I'm going to say again, I know the numbers are 6 and 2, but this time they're both negative. So negative 6 plus negative 2 is negative 8, and negative 6 times negative 2 is positive 12. So that works for us. All right, this one here, same thing. I want you just to think for a moment what two numbers are going to add to 6 and multiply to 8. Hopefully you've come up with the solution 4 and 2. So 4 plus 2 is 6. 4 times 2 is 8. So my two numbers are 4 and 2. All right, same thing here. What two numbers are going to add to 22 and multiply to 121? I'm going to give you a second to think about that. Well, if you know your times tables well enough, you should have come up with the number 11. 11 plus 11 is 22, and 11 times 11 is 121. Now, this is one of the special patterns we looked at the other day. So because both the brackets are the same, this is a perfect square. That just means the brackets are the same. And we can write this like that. So if you ever find a perfect square, this is the best way to write it. So make sure you finish it in this form. All right, now these ones over here are going to get a bit more complicated because our rule isn't going to work anymore. So just like we talked about expanding our brackets, you can't just say these two add to 8 and these two multiply to 15 if there's a number in front of one of these x's, and now there is. So this is going to complicate our life a little. So I need this term to be 2x squared, not just x squared like all of these. So I know that I'm going to have a 2x and an x. So this bit becomes a bit trickier. Now, I need to figure out what two numbers there are, and it's not just as simple as saying the factors of this. The factors of 6 are 6 and 1, or 2 and 3. So I don't know which set it is. So what I could do is just trial and error them, right? So I'm going to put in, and it matters which one is in which place as well. Whereas before it didn't matter, now it matters because this is going to affect what goes on. So I'd like you to have a think about, you can pause this video and just have a quick think about which one might actually go there. So I have discovered that I need to use 3 and 2. It might be deceptive to say 6 plus 1 is 7 and 6 times 1 is 6, but that's not true because of this. So I actually know, well, actually what I might do is show you a wrong version first. Okay, so let's say, for example, I know it's 2 and 3, but I'm going to put them in the wrong spot just to prove a point. Okay, so let's say I try it like that. So if I want to test whether this works, I can do my FOIL thing. So 2x times 3 is 6x, and 2 times x is 2x. So altogether that gives me 8x. Well, that's not what I wanted. I needed 7x. So let's flip them and see if it works. Okay, so 2x times 2 is 4x, and 3x times x is 3x, and great, those two do add to 7. So that is the solution that I need. 2x plus 3, x plus 2. Swapping them around made it incorrect. All right, so the same thing is true for this one here. And what I might do is deliberately try some wrong ones here. So 3x goes there and x goes here. Now I need to decide what goes in here. So again, I only have 2 options, thankfully. All of my factors are 4, so I can either choose 4 and 1 or 2 and 2. I just need to decide which one goes where. So let's try 4 and 1. Okay, so I'm going to try 4 and 1. And the good thing is I know they're both positive because both of these terms are positive, so that makes my life easier. So 3x times 1 is 3x, and 4 times x is 4x. They add to 7, so that's incorrect. Let's try again. So I'm going to swap them. 3x plus 1, 3x plus 4. Whoops, not a 3, that's just an x. So 3x times 4 is going to be 12x, and then 1 times x is x, so that gives me 13x. Well, that's wrong as well, so I know that's wrong. Now, because I tried both of these options, I know that's not right. It's got to be 2 and 2. And because the numbers are the same, it makes no difference what goes where because they're the same anyway. But I'm just going to check to make sure it works. 3x times 2 is 6x, and then 2 times x is 2x, and together they make 8x. Fantastic. There is my solution. So these ones are going to be a little bit of trial and error, but there shouldn't be many things to try. It's just whatever the factors of this last number are, and in our case we only had 2 of each, so you don't have to spend an hour trying different numbers. Okay, let me know if you need some help. Come and ask me any questions. Otherwise, good luck.